All right, guys, this is board problem 34. If the probability of A is 0.24 and the probability of B is 0.52, and A and B are independent, what is the probability of A or B? Okay, you see some choices right here, and a real common error is people want to just add these two together and get 0.76, but the answer is not D. And here's why, you guys. You remember this formula right here from a couple days ago, the probability of A or B? Remember, if the circles are overlapping, then that center part gets counted twice. So what we have to do is subtract off the intersection of the two. All right, now the key thing is they say they're independent right here. So if they're independent, then we use the multiplication rule for the intersection of the two. So probability of A and B is probability of A times the probability of B. So when you multiply those two together, you get 0.1248. So that's the missing part right there. You got to take off that 0.1248. So you're going to have the addition of 0.24 plus the 0.52 minus the 0.1248, and you get choice C. Okay? All right, so let's go back. This is just part two, you guys, of what we started yesterday. Refer to the section on section B of the prior notes showing the probability. And it was that diagram, that tree diagram that we made of high school athletes that made it onto pro sports or went through college and all that. Okay, so what we're going to do is show the totals at the end. We're going to do the probability of each tree diagram. So here's that tree diagram right there. Okay, and I shrunk it up a little bit. And we're going to calculate the ends of all of these. So what's the probability of this event, and then this event, and then this event, and then this event? Okay, so from here you're going to go 0.05 times 0.017, and that's going to give us this probability right there. Okay, and then here you're going to go 0.05 times 0.983, and that'll give us this probability right here. All right, and for those bottom two you get that. And those should total up to 1 all the time. Okay, remember that tree diagram about the transplant or the dialysis? That totals 1 also, and we're going to reference to that later on here. Okay, so what's the probability that a male high school athlete reaches pro? All right, let's go back to that tree diagram right here. Here, remember, pro was they got to B right here. So here they got pro, and here they got pro. This was Kobe or LeBron right there. So what's the probability they get to pro? You just add those two scores in there, so you get 0.000945. Okay? All right, and then let's go back to the definition of conditional probability. Sorry about my shorthand right there. And this was a form, this is Bayes' rule. So when you see Bayes' rule in the title, this is the formula. The conditional probability of A given B is this formula, you guys. And this says this, the probability of that A happens given that we know B happens. And so we find the intersection of the two and we divide it by the probability of B. Okay, now so let's go ahead and do an example here. So what's the proportion of the pros who compete in college? Now we did this before. I'm just refreshing you guys. So this is asking you, what's the probability that they went to college given that they went pro? Okay, what's the probability that they went to college? Remember that was A, given that they went pro. Okay, and uh, so the probability of A given B. Should be given B, sorry about that, okay? And not give B, it should be given. All right, and I'm just shrinking it up just so we can see all this stuff right here, okay? So the probability of A given B, okay, we found this one in the prior one right there. It was at 0.000945, I think, or I'm sorry, that's the bottom one right here. The probability is they went pro, we added those two scores together where they went pro here and up here, so that was the bottom. And the probability of A and B, here's A and B, is that 0.085, and you get 0.8995. Okay? So what I want you to do is go back over that tree diagram that we discussed on page 376. It was that dialysis, and just familiarize yourself with that tree diagram, and then continue reading the bottom of page 376 and most of 377. I want you to go over that, and then you're going to be assigned some homework that goes with that.